Can you find the radius? Let's do a 90-degree turn, clockwise.
Let the circle have radius r, and let the distances from the center of the circle to the chords of lengths 10 centimeters and 24 centimeters be D1 and D2 respectively.
Let's extend the line to create a chord. Since the 10 centimeters chord is parallel to this chord, the extension is 7 centimeters, which makes the entire chord 24 centimeters long.
For any chord of a circle, the relationship between the radius, the chord length, and the distance from the center is r squared equals d squared plus 1/2 chord length squared. For the chord of length 10 centimeters, r squared equals d1 squared plus 10 halves squared equals d1 squared plus 25 for equation 1. For the chord of length 24 centimeters, r squared equals d2 squared plus 24 halves squared equals d2 squared plus 144 for equation 2. Since the two chords are parallel and 7 centimeters apart, the vertical distance between them is 7 centimeters. Thus, we have d1 minus d2 equals 7. Subtracting equation 1 from equation 2 yields d2 squared plus 144 minus d1 squared plus 25 equals 0. d2 squared minus d1 squared equals negative 119. d2 minus d1, d2 plus d1 equals negative 119. Assuming without loss of generality that d1 greater than d2, then d1 minus d2 equals 7. Therefore, we rewrite negative d1 minus d2, d1 plus d2 equals negative 119. 7 times d1 plus d2 equals 119. d1 plus d2 equals 17. Now we have a system of equations. d1 minus d2 equals 7. d1 plus d2 equals 17. Adding these two equations, 2d1 equals 24. d1 equals 12. Subtracting, 2d2 equals 10. d2 equals 5. Substitute d1 equals 12 into equation 1. r squared equals 12 squared plus 25 equals 144 plus 25 equals 169. r equals square root of 169 equals to 13. Thus, the radius of the circle is 13 centimeters. The geometry of circles, as illustrated by problems involving chords, distances from the center, and associated relationships, has numerous practical applications in real life. Here are several areas where this kind of reasoning is valuable. Architecture and engineering. When designing arches, bridges, or domes, engineers and architects often work with arcs and chords. Understanding the relationship between a chord's length, its distance from the circle's center, and the circle's radius can be essential for calculating the curvature and stress distribution of these structures. Mechanical engineering. In the design of gears and circular components, like arches, flywheels, or rotors, knowing the properties of chords can help in setting precise tolerances and ensuring balanced mass distribution. Chord properties may be used in the design of cams and other rotating machines where conversion of rotary motion to linear motion is required. Astronomy and navigation. In celestial mechanics and navigation, circles and chords are frequently used in coordinates and projections. For example, in star charts or when plotting trajectories. The concept also underpins methods used in triangulation and satellite positioning. Construction and surveying. When constructing curved elements, such as roads, railways, or landscaping features, surveyors and civil engineers may use the properties of circles to determine curve radii and chord lengths. This ensures that elements are built to proper curvature to meet design specifications. Computer graphics and robotics. In computer graphics, the principles of drawing circles and arcs are crucial in rendering curves accurately. When creating realistic animations or simulations, using the mathematical relationships of chords helps in smoothing out transitions. In robotics, path planning or the design of robotic arms that follow a circular trajectory often involves calculations based on the properties of circles. Optical systems. In the design of lenses and mirrors, understanding the circular sections is crucial. For instance, calculating how a light ray interacts with a lens may involve understanding chords and arcs, which can help in reducing distortions like spherical aberration. Civil engineering designs. When designing roundabouts, curved roads, or even large circular plazas, the geometric relationships help determine the correct dimensions and ensure smooth traffic flow or aesthetic appeal. In summary, the principles learned from solving geometric problems involving chords and circles serve as the foundation for many real-world applications, ranging from designing safe and efficient infrastructures to developing high-precision mechanical components and innovative digital visualizations.
Thank you for watching. Like, share and subscribe.